Deal. We need 100% focus and attention today, more so even than usual. Sydney, if you can kill the lights. Because yesterday, we had a productive lesson yesterday, but we didn't get quite as deep into inequalities as I wanted to. There was still another question that we needed to get to, and we didn't quite get to it, and it had a very important point behind that question. So we will do such today. All right, by the time we're done with today's lesson, everything will be completely covered. But you're going to have to really have your head in the game. Okay, so which of the following choices is in the solution set? And this is a danger question.
I already figured it out.
All right, what do you think the answer is, Anthony?
I think the answer is 3. No, sorry, it's -3 because what I did was that
Yes, you're good.
I multiplied -2 and -3, which got me 6. Then I did 6 plus 7, which got me 13, and 13 is less than 15.
That's right. So Anthony substituted in the -3 and he checked it. And he came up with the perfect answer. But I want to show you what a lot of kids will do. And it's not that what they're doing is bad. It all goes back to that whole idea of Numberland in cyberspace. And this is why I took the time to explain that yesterday. Check this out. If you do -7 and -7, die, I get -2n is less than 8. And now we're getting, you did these last year, right?
Yeah.
Good. Now you're getting into something that you may have forgotten from last year. And then you're getting into a detail that's all about that whole Numberland idea. I need to divide by -2. Now, the first thing I want you to notice is with an inequality, when you multiply or divide by a negative, not into, by, what did I just say? By a negative, you have to switch the symbol. Okay? That was what was in the question we didn't get to yesterday. Whenever you multiply or divide by a negative, you must switch the symbol. Now, I want to go back in time just a little bit to the first couple days of school. And I don't do this with you because we just don't have time in this course. But I do this with my 8th graders. And I learned a long time ago that if I teach how to add, subtract, multiply, and divide integers, if on the first lesson I teach how to add integers to the kids in my class, and I give a quiz on it the next day, the kids will get, just about every kid will get them all right, and you'll get 100 in your class for adding integers. And then for subtracting integers, that one kids will bother a little bit of a hard time, but if I do 2 days on subtracting integers, and then I give a quiz on both adding and subtracting integers, I will get pretty much 100 from every kid in the class. Then if I give a kid a quiz on multiplying and dividing integers, and I mix it with adding and subtracting, the kids will bomb it. And you would say to yourself, why is multiplying and dividing so hard? And the answer is no. The problem is the rules. If you learn it the old way, the way a lot of teachers teach it, they say the following. If you, with addition, add the numbers, keep the same sign. But then with multiplication and division, the rule is if the signs are the same, it's positive. If the signs are different, it's negative. And those rules sound so alike that kids start confusing when you apply which rule. So going back about 20 years ago, 25 years ago, I changed how I teach this. And I never, ever, ever use this rule about multiplying and dividing and if the signs are the same and if the signs are different. Because it's far more confusing than it is successful. Check this out, this is very important. If I multiply by a positive number by 2, I multiply and I keep whatever sign I started with. It's -10. Because this really means I have 2 -5s. And if I have 2 -5s, what do I have? Guys, head in the game. If I have 2 -5s, what do I have? -10. Now, if I do 5 times -2, the answer is also -10. But it's not because the signs were different. Someone just noticed that that happened to be true and they made up a rule. But that's not why. One way to look at this is that you have 5 -2s. And if you have 5 -2s, you have -10. But another way to look at it is, when I do 5 times -2, I'm not only multiplying by the 2, I'm also multiplying by the negative. Now, what do you do when you negate something? When you negate something, you change its essence, what it is. For example, girls, you have a man, a boyfriend. And your boyfriend treats you like dirt. he does something really stupid. Like, for instance, you come up to him in this brand new dress, and you look at him and you go, "Oh, sweetheart, does this dress make me look fat?" And he says, "Yes." This is not a good situation. Your man has screwed up big time. You are now ready to kill him. Okay? He is about to die the most horrid death humanly possible. But the moment the words leave his mouth, and he says, "Yeah, oh God, I'm so dead." The minute those words leave his lips, he immediately sprints to the store and buys you an 8-foot teddy bear. And then he goes and he gets you the world's best chocolate. And then he goes and he gets you Chinese food.
Yeah.
And then he goes
I don't like Chinese.
and he gets you tickets to your favorite band's concert.
I don't have a favorite band.
Well, you're not a girl. So then he runs back. He runs back and he gives you all of those presents. Has he made up for it?
No.
No.
No, you're gonna have I'll have to go.
Now, here's all humor aside. Listen,
You're trying to make me
Listen.
mad by giving me ice cream and Chinese food?
listen. All kidding aside, listen, here's the thing. What he's trying to do is make up for something he did that's wrong. He's trying to negate it. We could put the shoe on the other foot. Let's say that he did something really good. Let's say that you went out to dinner and he bought you your favorite food at your favorite restaurant. He opened the car door for you. He treated you really well in front of your parents. Your parents are with you. And he was polite and respectful. And he did all of this really nice stuff, and he created this wonderful positive impression. I remember Jimmy brought a girl home once. She was such a sweetheart. And as soon as we were done with dinner, she just looked at us and said, "No, no, no, Mr. and Mrs. Nyquist, you just sit down. I'm going to do the dishes." And we were in heaven. We were like, "Oh, yes, this girl, marry her.
What happened to her?
Marry her."
What happened to her?
So he does all these wonderful things, and then at the end of the night, he says, "So, yo, Pops, man, your daughter," and he starts saying bad things about you. Wouldn't he have negated all of the good work for the evening that he did? Right? Can you imagine the look on your father's face if he starts insulting you in front of him? Your father's going to kill that young man. I could see the News 12. Here we have Mr. Bacon from Patchogue arrested tonight because this young man decided he was going to, and they're dragging about with the purple, you know. And then actually your father would be going like, "Yeah, do it again, I'll kill you 10 times before this thing's over." The whole idea of negating is to switch it, to make it its opposite. If you did something that was really, really good, and you negate it, you've now made it really, really bad. And if you did something that was really, really bad, and you negate it, now it's what? Really, really good. So when you divide by the negative here, or I should say multiply by the negative, you are changing what it was a positive 5 to a negative 5. So you just do the numbers, and then if you multiply by a negative, or divide by a negative, you have to negate it. That's why we say negative. Negate. Same idea. So here I'm going to do negative 5 times negative 2. And negative 5 times 2 would have been negative 10, but I also have to negate it, so it comes out to positive 10. So that's how I teach every kid in Math 8 how to multiply and divide integers. Now, why do I bring that up? Because if you look at this problem, it's the same idea. Watch. I'm dividing by negative 2. I have to negate the positive 8 and dividing by 2, so it comes out to negative 4. But you know what else I have to negate? I have to negate the sign. If I say to you, I weigh more than 300 pounds, and I negate that, what can you say? I weigh less than 300 pounds. If I say I got below a 75 on a quiz, and I negate that, what do I get? Above. So you also have to negate the sign. So here the sign is less than, but when I negate a less than sign, what do I make it? A greater than sign. So that is why when you multiply or divide by a negative, you have to change the sign. Anthony had a question.
I think the only time number 1 would be C if only it said less than or equal to.
Yes, and that was the last point I wanted to make. Thank you. The last point I wanted to make is this. I said that this has to do with the whole idea of numberland, okay? In an equation, if this said equals, Forget the less than. If it said equals all the way through, the answer would be -4. So there's a tendency on kids' parts to get to the end, see -4, look at the choices, see -4, and think -4 is the answer. But no, what does this answer read? Any number, that's what? Greater than, oh, you know how to tell the less than from the greater than symbols, right? I used to forget them all the time, so don't feel that. Listen, anybody who tells you about this crocodile thing in the alligator mouth,
Oh my
I
god.
can't stand it. I
Why?
hate it.
Oh, it's so useful.
No, it's a trick, it's a gimmick. Math makes sense, there's always logic for math. Ready? Look at this, see this? That's the less end of the number line,
Yeah.
that's the greater end of the number line. That's where the symbols, that's the origin of the real symbol, okay?
That makes
All right, it's perfect sense. It's so logical.
And then when you
Um,
plot it on the
and
line,
elementary teachers don't see that. I hope I'm not picking on anybody's parents here, but that's just the way.
Oh, like whatever side it's closer to, that's the sign you use?
Well, no, if I use this sign, that means I wanna be less, I wanna go to the left.
Okay.
And if I'm greater than, yes?
What about like the less than symbol that it makes like the L? We like that.
I don't like, I don't like anything that makes math look gimmicky. I want math to be logical. Do these things work? Quite possibly. And they might work for some and not for others. But I want math to make sense. I want it to be logical. I want to gain a measure of respect. If I'm sitting in a class, and maybe this is just me, but if I'm sitting in a class and the teacher basically comes in with a long list of things I'm supposed to memorize because they think that these are all tricks to make something good, I might be able to memorize the list, but I don't see any value in learning the material. But if you show me that there's this logic and reasoning and it all makes sense and you could put it all together and then I can take this skill and I can apply it to the real world, now I'm saying, you know what, this has some value. It's not, there's an alligator chasing a number. No, I don't like that. Okay, so once again, I got a little distracted there. Look, if I read this, this says the number is greater than -4. Look at the choices. What's the only choice that's greater than -4? Everybody? -4. Okay? Likewise, is this gonna have a greater than or a less than symbol in it? The next one. Greater than, look, here it is, it's right at the end of the number line. I can't give it to you any better than that, right? All right, the n goes here. Do I put a little line underneath?
No.
No, because it's not filled in, and that would be 0. So n is greater than 0, also known as the positive numbers.
Wait,
Yes?
so
What
open,
is that one between these?
but what happens if the numbers are flipped around and it's n, so there's a 0 here and then the whole thing is flipped around and the n is on the other side?
Yeah,
And
what we
some-
always say is this, always put the n on the left. Now, let's say we had done this. These two statements are exactly the same. Think about this from a word point of view. Don't think about it from mathematical, just English language. The numbers are greater than 0. 0 is less than the numbers. Isn't that the same statement?
Yeah, but I feel like, that the reason why I use the crocodile thing, even though I'm still, that's babyish, I guess, is because no matter the way it is, I know that whatever it's eating is greater.
Me too. And greater than 0.
No, but I mean like, you should know how it shows it like that, and you said that the greater. shows it
0
like that.
less n.
But it's this way.
I'm
It's
not
just- it
arguing
just
that,
reminded me.
I'm not arguing that it doesn't make sense and it's not true. That's not the point I'm arguing, all right? An even easier way to know it than an alligator mouth, ready for this one? It always points to the little guy.
Huh?
It always points to the little guy,
Like it's laughing at
Oh,
it.
right?
Like it's pointing at it and laughing.
Yeah, like, ah, you're little, all right? So, you know, whatever gimmick you want. But I wanna have respect for this. I wanna know that what I'm getting out of it has some value. Okay, let's go on to number 3 now. Oh, by the way, listen, hey, very important. There will be times with inequalities when the letter's on the right, like this. We always wanna move it so the letter's on the left. The reason we wanna move it so the letter's on the left is so it's easy to grab. What we do is this, listen very carefully, ready? These two statements are the same statement. If it points to the 0 here, it points to the 0 here. That's all you gotta do, and the statements are the same, okay? All right, now, this guy, ready? Remember to cube everything in the parentheses, that's -125 n to the 9th. Sometimes kids forget to cube the -5, and they just write -5 n to the 9th. But everybody gets the n to the 9th. It's the -5 part that they sometimes screw up. It needs to be -125. This guy, simplifying, I gotta square this, which makes it 4x to the 6th. Okay? Same idea, you gotta square the 2 in front. Now 4 times 4 is 16, x to the 7th, right? Because I do the 4x times the 4x to the 6th. And then 8 goes into 16 twice, subtract exponents, 2x squared. That can be a little bit tricky for kids, and you might need to work on that a little tonight. Negative exponent.
Reciprocal.
Good, so let's take the reciprocal. I make it 3/2 squared, which is 9/4. Okay? Any questions?
No, sir.
Nice, there we go. All right. You guys do numbers 1 and 2. Go ahead, 1 and 2. Okay. How do your answers look compared to mine?
Same.
Looking good?
Same.
Okay, I have a couple quick questions for you. The first one, is 0 an answer?
No. Well, it could be 1.
Yes. How come 0 is an answer?
Zero is a number.
Because it's less than 3.
Never mind.
Okay, is 100 an answer?
No.
Not because it's not a number, all right?
Well,
Now,
it's
because it's,
more than 3.
that's right, it's more than 3. Good. Is 3 an answer?
Actually, way more than 3. No.
Is 3 an answer, everybody?
No.
No, why?
Because
Because everybody, why?
you would only use it if it was less than or equal to.
Or if the symbol said that, right. In other words, 3 is not less than 3. Let's come over here. Is 0 an answer here?
Yes.
Yes. Is 100 an answer?
No.
Is 2 an answer?
Yes.
Why? Because it's what?
Less than or equal to.
That's right, it's or equal to. Okay, very good, okay. So now we get to our last question of the day. Everybody, what do you think the first step is? Everybody, what do we do?
You subtract 5 from
Good.
7.
Nice. Die. Negative x over 4 is
Well,
less
that
than
equals
2.
negative 1/4.
Right, that is negative 1/4. Now, on your calculator, you can divide by negative 1/4.
Or you could just do some reciprocal.
You could, definitely. There's nothing wrong with that. You could also, you could kind of cross multiply here,
Hey.
right? But let's just do this, ready? I like to look at it as multiply by negative 4. Because this is being divided by 4. What's the opposite of to divide by 4?
Multiply.
Multiply by 4. And I have to undo the negate symbol.
What?
So I get x is now, I multiplied by a negative. So what do I have to remember to do?
Negate.
Negate, very good. And negate means I have to switch the sign. So less than becomes greater than. X is greater than negative 8. So the big thing is, if you multiply or divide by a negative, what do you have to do to sign every time?
Change it.
Switch it, change it, negate it. Okay. By the way, is 0 an answer to this?
No.
Yes.
Yes.
0 is greater than negative 8. Is negative 8 an answer to this?
No.
Is 100 an answer to this?
Yes.
Yes, very good. Yes.
The reason why 0 is an answer is because it's not saying that the negative 8 is greater than 0. It's less than, because if you go left, going right? Great.
There you go. All right, how much time do we have left? Almost every person in here got 100 on the last quiz. So if you got 100 on any of the three, you can go there and grab either one cookie out of the bag or one piece of candy.
I already had some cookies.
Okay.
Well,
Hold the bag, take one cookie, not a whole bag, one cookie out of the bag. No whole bags. You can take a juice instead if you want to.
You can't have.
No, you can't, not a whole bag, one cookie out of the bag. Because that's gotta last for a couple of classes here.
Juice! I gotta get here.
It looked like that was an act of worship.
Thank you for the juice.
You're welcome. You're welcome.
I love juice.
You're welcome. Have a great day, folks.
Wait, Kristen, get my calculator.
Nice.
Kristen, can you?
Very cool, buddy.
Alg Ch.
Only because I'm like,
Full row.
I got your calculator.
All right, have a great day, folks. Get your drink.
Young.
What's that? Oh, yes, I did. I screwed up. I'll work on that for tomorrow.